if we look by problem 3, what's going to happen on some of these problems is the factors are not exactly going to cancel. They're going to almost really look similar to each other, but not quite. And what's the case there is that we have opposites. So in this example here, we've got x minus 3 over 3 minus x. Well, the numbers and variable stuff's the same, except the signs are opposite from each other. So to simplify that, what you can do is factor out a -1. So what they did is they took the 3 minus x and they said that's the same as -1 times the quantity -3 plus x. Because think about if you distribute that, -1 times -3 would be a +3, -1 times x would be -1x. So that's the same thing, just we factored out a -1. And -3 plus x, if you just rearrange that. So if you look at this then on problem 3, it's going to be a similar setup. And what the book does here is they went ahead and factored it, and then they try and factor out a negative. I would probably approach this a little bit differently than they did. What they did is fine, but I don't really like this negative exponent stuff that we normally haven't been seeing. So what I might do is take the numerator and factor a -1 out of the numerator first. And then that would leave me -4 plus x squared. Notice in the denominator we have a greatest common factor of 7. And then if you just rearrange the numerator, it's going to look real familiar to us in a minute here. Just switching those around, that's going to be x squared minus 4 in the numerator. And that, you might remember, is a difference of squares that we can factor as x plus 2 and x minus 2. And then the x minus 2 factors will then cancel out. You can technically leave it like that. I don't really care for how the book left it with just having the negative sign right next to the fraction bar, because if you're sloppy at all, that negative bar or negative sign and fraction bar are going to blur together and you're not going to see it at all. So I kind of actually prefer writing the answer this way. A little bit easier to see the negative sign there. So we look at the got it 3A. These are, you could put parentheses around. Remember, don't try and cancel anything at this point. But these are very similar to each other. It's kind of a choice of which one you like better, or it really doesn't matter. But these are real similar, just we need to factor a -1 out of one of them. So which one do you want to factor it out of?
The bottom.
Okay. I heard a mixed result. So we got to vote on this. How many want to do the top? 3. How many want to do the bottom? 4. Okay, we will factor a -1 out of the bottom. I kind of do like that 2x minus 5 just because a lot of times, you know, it's kind of our standard form we've talked about. Anyway, when you factor out the -1, if you guys know what's coming and you want to just say, I'm pretty sure this is going to be a 2x minus 5, you're welcome to do that. Just do double check, distribute it, and make sure, is that the same thing as 5 minus 2x? It's -2x and then be plus 5, so that is the same then, right? If it helps you to do the other step, keep it in the same order first and then rearrange it, then go ahead and do that. But what's going to happen then, the 2x minus 5s are going to cancel. Before that, we probably should have looked for excluded values. So that factor cannot equal 0. -1 is not going to equal 0 anyways. Close. It'll be 2.5, yeah. So x cannot equal 2.5. And then with those canceling, we just have a -1 left. Remember, in the numerator we don't have anything, but we could put a 1 there. And then this, we can get that. 1 divided by negative 1 would be negative 1. So negative 1 would be our simplified answer as long as x is not equal to 5/2.
Did you ever guess that?
Yeah, that didn't work. Look at part C. And we're going to try to figure out what's going on with this one. The first thing I would be tempted to do, I kind of like how the denominator looks, so we could try to factor that potentially. It does have a 6d squared. I'm going to try 3d times 2d to get 6d squared. We got a -1, so we would need what? Plus and minus, okay? And they're both going to be 1s. This is not going to quite work though, is it? Minus 3d plus 2d. That'd be minus 1d, so we're just going to switch our signs around here if we can. So switch it to that, and then we should be good. Now, in the numerator, we should be coming up with something similar if they're giving us anything at all to do with this problem. There's 2 terms here, so we can factor out a common factor. Looking at the numbers, I would say 3. Now, if we just factor out a 3, that's going to leave me with 1 minus 3d. That's going to be very similar to something in the denominator, so we may actually want to factor out a negative 3. Okay? If you don't want to do it all in one step, that's okay, but that's going to be eventually what we're going to have to do. You factor out a negative 3, and then negative 3 times what to get 3 would be negative 1. Negative 3 times what to get negative 9d would be 3d. And then if you think about that, rearranging, that's the same as 3d minus 1. And then we're allowed to cancel out the 3d's minus 1's. I kind of just suggest maybe putting the 2d plus 1 in parentheses, keep it in parentheses just in case the numbers are right and you might be tempted to cancel something that's not actually a factor. Excluded values then for this first part here would be that d can't equal 1/3 if you work that out, and for the second one would be negative 1/2. So these would be our 2 excluded values then.